Okay, hi everyone. So today you're going to be looking at the identities in algebraic notation. So your LO is there to know the difference between an identity and an equation. But first of all, we're going to do our retrieval practice. So if you can spend 7 minutes working through these problems here, and then we'll go through them. So pause the video now. Okay, so here are your answers, guys. Make a note out of 6 for how many you've got right. Try and spot if there's any patterns in your work. Did you struggle with turning decimals into percentages? Make a note of this because you can always go to Hegarty Maths or go online and try and strengthen in that area if you're struggling each time with a certain aspect of our retrieval practice. Take a moment to think about where you could strengthen or where you're currently strong. Okay, so let's get on to looking at an identity. So we can see the symbol here at the top of the page here. So the way I like to think about it is it looks like an equal sign, except there's another horizontal line. So the way that I remember that this is different from equals, as I say, it's even more equal. It's more than equal. It's extremely equal. Whatever way you want to try and think to imprint in your head that this links with our definition. So let's look at the definition. So an identity is an equation that is always true no matter what values are chosen. So let's look at an example. So below this here we have one variable, a. Have it here, here and here. Let me get my pen out for you. So we've got three variables. We've got a, and a, all the same variable. We have an equal sign, so it's definitely an equation. But is it also an identity? Can it be an identity? So we know from our last few lessons that 3a plus 2b, 3a plus 2a are both like terms. So if we wanted, we could collect these and they would become 5a. So on the left hand side we have 5a, and on the right hand side we have 5a. So they are, no matter what value of a we put in here, the left hand side is always going to be equal to the right hand side. So this is actually an identity. The way that we can check this using our success criteria is we said if there's terms to be collected, we can collect them, so that we know that the right hand side, we've had a look and we know that 3a and 2a are both like terms, so they can be collected to make 5a. Also, what we see on our bottom success criteria here, number 4, is we could try values. So let's try a's equal to 3. So on the left hand side we have 5 times 3, and on the right hand side we're going to have 3 times 3 added to 2 times 3. So as you see there, our a here has become 3, our a here has become 3, and our a here has become 3. So let's calculate both sides. 5 times 3 gives me 15. And now on the right hand side, we have 3 times 3 gives me 9, added to 2 times 3, which gives me 6. If I add these two together, I'm going to get 15. And no matter what value you try, you can say, let's try a is equal to 5. Let's try a is equal to 6. No matter what value of a you put into the left hand side and the right hand side, you will always get them both equal. So because this is always true no matter what value of a we have chosen, that means that this here is an identity. So let's have a look at going through some examples. So here we go. So we need to state the correct symbol between each of the expressions or constants. So is it more appropriate here for us to put an equal sign in here or an identity symbol? So let's treat this like the left-hand side and this like the right-hand side. So if I look at my left-hand side, I have a 12, which is a constant, and I have 3x. So they're two terms that aren't like. So we can't simplify that. So let's look at our right-hand side. So we have a 5x, and we have a negative 2x. We then have a positive 10 constant and a positive 2. So we can simplify the right-hand side. So let's do that. So I'll just leave the left-hand side. And on the right-hand side, I have 5x, subtract 2x, which leaves me with 3x. And then on the, put another bubble here, because we don't know what we're putting here yet. And then we also have a positive 10 and a positive 2, so that's plus 12. Now, if we look at our left-hand side, 12 plus 3x, it's the exact same as our right-hand side. It's just the order of our terms has been changed. So no matter what value of x we put in there, it's always going to be the same. So that is an identity. If you can now pause the video and give yourselves 1 minute to decide which is more appropriate now to go in this place. Okay, so again, our left-hand side cannot be simplified. Our right-hand side looks like it can. There's a lot more terms. There's a lot more going on. So let's look at our right-hand side. So we can collect the 10 and the 2, and we get 12. And then we've also got a positive 2x and a positive x. So that gives us 3x. Now, if we compare that to the left-hand side, which we've got 12 plus 3x, again, our 12, the constant's the same, and 3x is the same. So this is always going to be the same, no matter what value of x we put in there. Feel free to try it if you want. Try and put in x is equal to, I'm not sure, 4. Try and give it a go if you'd like. So we'd get 12 plus 3x on one side, which is 12 plus 12, so we get 24. Then on the left-hand side, on the right-hand side, sorry, we get 12 plus 12 again, so we get 24. So that works. I would usually avoid, if you want to convince yourself like this, I'd usually avoid using x is equal to 0 or 1, because usually that will throw up some special cases where you might get answers that are equal, but potentially it isn't a identity. So let's have a look at some more. So again, our left-hand side is simplified. Our right-hand side has some terms. So here again, we have 10 and 2, which can be collected to give us 12, and we're left with just plus x. So on the left-hand side, we have 12 plus 3x. Okay, so these, the 12s are the same, but we have 3x over here and 1x over here. So this is not going to be the same. This will not be the same for all values of x. So the symbol that we would put in between would be equal. And we've now created ourselves an equation. Not an identity, an equation. Because let's have a look. Let's try a number in here just to see what it will do. So let's try x is equal to 2. So on the left-hand side, we have 12 plus 3 times 2, which is 6. And then on the left-hand side, we have 12 plus our x, which we've chose is 2. So on the left-hand side, we've got 18. And on the right-hand side, we've got 14. So that is not equal. So you see, this equation here is not correct for every value of x, because it's not correct for x is equal to 2. So pause the video now and give yourselves a minute to decide on the symbol that should be in between these two expressions. Okay, so again, so the left-hand side is simplified. The right-hand side, we need to simplify. So again, we have a 10 and a 2. So we have 12 when we collect these together, and 2x. So therefore our 12 is the same, but our 3x and 2x are not. So it's most appropriate to put an equal sign in between. Okay, so let's have a look at these ones. So again, our left-hand side, there's a pattern here, is simplified. So the right-hand side is the one that we need to have a play with. So again, we have a 2 and a 2, so our constants can be collected. So we get 4 on the right-hand side plus x, because there's nothing for the x to simplify with. So now let's look at the left-hand side. We have 12 plus 3x. So we have 12 and 4, so our constants aren't the same, and our algebraic terms, the 3x and the x, aren't the same. So it's most appropriate to put an equal sign and create this into an equation, because this is not going to be correct for all values of x. So it's not an identity. So now let's look at, well, actually, now can you pause the video and spend a minute trying to solve the redo? Okay, so let's have a look. So again, it's the right-hand side that needs simplifying because there's more than 2 terms. And we only have 2 over here. And they don't simplify on the left. We have a constant and a variable. So again, we can collect our 10 and our 2, and we get 12 plus x again. On the left-hand side, sorry, we have 36 plus 3x. So these here are not going to be equal for all values of x. We have different constants on each side, and we have different algebraic terms. So it's most appropriate to put an equal sign in here. It is interesting to look and see that we could have took a factor out here. This is just a little add-on. We could have took a factor of 3 out here on the left-hand side. So if you have a look, so if we take out 3, we'd end up with 12. And we'd also end up with x. So do you see there how the left-hand side is 3 times larger than the right-hand side? So again, this is not going to be equal on both sides for all values of x. But we still can solve this to find what values of x this is correct for. Okay, so now we've got some brackets to expand. So that is the first on our success criteria. So we need to look to the right-hand side. This can be simplified. So let's multiply 3 by every term. So 3 times by 10 gives us 30. 3 times by x gives us 3x. And 3 times by 2 gives us 6. So we can simplify this now. We have 30 and 6. So we have 36. And then we still have the 3x. So we can now compare that to the left-hand side, which is 36 plus 3x. And as you can see, they are going to be the same on both sides. So that, excuse my awful identity sign, that is an identity. Because the left-hand side is always going to be equal to the right-hand side, no matter what value of x we choose. So can you now pause the video and spend 2 minutes trying to solve the we do? Be careful when you're expanding this now. Okay, so last time I multiplied 3 by everything. What I'm going to do this time is I'm going to notice that inside my bracket, this simplifying I can do before multiplying. So let's look at the right hand side. So we have 6 multiplied by the 4 plus 2 can become 8. Oops, sorry. Let me get my rubber. Obviously, I know that 4 plus 2 is going to become, and then we're left with just the x term. So now we can multiply this out. 6 times by 6 gives me 36. 6 times by x gives me 6x. So now let's look at the right-hand side, the left-hand side, sorry. So we have 36 plus 3x. So if we compare the constants, 36 and 36, if we compare our algebraic terms, our variables, we have 3x on one side and 6x on the other. So this is not going to always be true no matter what x we put in there. So this is going to be an equation, not an identity. Okay, so here's the final one before we move on to some independent practice. So again, we've got our left-hand side here, and our right-hand side is the one that's all singing, all dancing. So let's look at analysing this one first. So again, we have inside our brackets, there's some simplifying we can do. Even if you just multiplied out by every term and then simplified, you'd still get the same answer. It makes no difference. So on our right hand side, we have 6 times by 4 plus 2, which is 6 plus x. And then it's all divided by 2, everything. So we know from our last example that 6 multiplied by 6 gives us 36. And 6 times by x gives us 6x. And then it's all divided by 2. So I'm running out of space. So I will just show. So if we're dividing everything by 2, our 36 divided by 2 would give us 18. And our 6x divided by 2 would also give me 3x. So it's half of 6x is 3x. So now let's look at the left-hand side, which was 18 plus 3x. Okay, so as we can see, our constant's the same, our variable's the same, therefore this is an identity. So now pause the video and spend 2 minutes trying to solve this redo. Okay, so now let's have a look at this. I'm a little bit short for space here. So on our right hand side, we have 9 is going to be multiplied by everything inside the bracket, and inside the bracket we have 6 plus x, and it's all going to be divided by 3, everything. So we end up with 9 times 6, which we get 54, plus 9x, all divided by 3. Not doing too bad for space. And then finally, 54 divided by 3 is going to give me 28. No, it's not. It's going to give me 18. Here we go. So it's going to give me 18. And then 9x divided by 3 is going to give me 3x. So now let's compare this to the left-hand side. So we've got 18 plus 3x. And all I'm doing is I'm just bringing that down so I can compare them. So the constants are the same and my variables are the same. So this is always going to be the same no matter what value I put in here. If I put a 1 in here and a 1 in here, both sides will be the same. Just let me show you that. So if I pick 10 to be in here, I'm going to have 18 plus 30. And if I put x, I've chose x to be 10. So if I put 10 in here, I'm going to have 18 plus 30 again. It's always going to be the same on both sides, no matter what value of x I choose. And that is the definition, what makes an equation an identity. So we need to draw our third line here. Okay, so make a note of how many you got right on the redo, guys, yeah? Now, make sure that you pay attention to our success criteria that's at the bottom. It's there to help you. It's tips if you get stuck or just want a little bit of guidance or modelling as to how you go through it. So, if you can now pause the video and spend 5 minutes working through these problems here. So I'll just try and highlight for you so it's a little bit more clear where the left hand side and the right hand side are, so where your symbol would be going. So first of all, decide whether it's the left hand side or the right hand side that you can play around with. Decide which one can have more simplification, which one you have more to play with. So pause the video now and give it a go. Okay, so here we go. As you can see, in the red on the solutions, we have the symbol. So if we have this symbol here, we've ended up with an equation. And if we have this symbol here, we've ended up with an identity. Okay, so now we're on the final page now, guys, of understanding identity and equation. So the first task states circle the phrase in green and circle it in red if it refers to an identity. So if you want, you can just do a title. You can do equation and list the things that relate to an equation, and do a column identity and do it like that if you prefer. Then I want you to move on to these here. So I do want to make a note now, guys, that you are trying to put the correct symbol in between, but with some of these later ones, because I wanted there to be a bit more of a challenge, you may have to manipulate the left hand side and the right hand side. So if you see here, you have brackets on both sides. So expand them, collect your terms, do the same on the left hand side, and then compare the terms and see if they are an identity or an equation. Will they be correct? Will they be equal for all values of x? There is some manipulation. These last ones at the bottom as well, there's a lot to play around with here. So give yourself some time to do that. Pause the video and spend 7 minutes working through these, guys. Okay, so let's have a look at the answers. So again, as you can see, the green ones, so if it refers to an equation, so it can be solved to find one or more specific values of x, but not all. An identity is true for all values of x. I've circled that in red. It uses the identity symbol and it will simplify to the same thing on both sides. And then that's what you're going to have to do down here. Discover, can you simplify them to get the same on both sides? These two here are the only ones that came out as an identity. So, wonderful, guys. Give yourselves a score and make a note of that so you can pass it on to your teacher and so you can reflect on how you did during this lesson. Is your understanding of equation coming on since you first learnt it 2 lessons ago? So this is the end of your lesson 1, guys. So what you need to do now is take some time to reflect on what you think went well, what you struggled with, how are you going to tackle the things that you struggled with next time. Now what you need to do is you need to go away and complete your Hegarty tasks that have been set by your teacher, and also complete the Google form that has been set by your teacher, or to email your scores to your class teacher. That's everything for today, guys. Thank you very much. Have a nice day.